So we have, remember we said we were going to go through and make sure we read thoroughly, because the people who get these questions wrong are just someone who misses something. You often know what you're doing, but you're missing something. Make sure your phones are away, because I'm doing this for you, not for myself. Okay. Vincent and 4 of his friends went to a restaurant for supper and had to stand in line. If they're standing in line, order matters, just so you know, because you can visually see them standing in line. If you can visually see them standing in line, order matters. If you can visually see something on a bookshelf, order matters. After the meal, they walked to the cinema to see a movie. Vincent got called to work, but everyone else stood in line for the movie to get into the theater. The number of different arrangements, remember the moment I told you it says the word arrangements, it's a permutation because order matters, because you're arranging something, it's a key word. Standing in line at the restaurant. Exceeded means more or less? More. The number of different arrangements, standing in line to see the movie. Okay. So how many people do we have for the restaurant? 5. So I'm going to go 1, 2, 3, 4, 5. And I'm going to draw it out so I can visualize them standing in line, right? Remember I told you if you ever stuck and you know you can visualize something, draw some blanks so you can see it. So how many people, okay, here I got my 5 people. How many are going in the first blank? 1, but yes, I have 5 options. I asked that really stupid. I'm putting 1 in there, but I have 5 options. That's the way I meant to ask it. Your answer is correct. Now I put 1 there, and the load of people of holding them is a little bit lighter, because now I have how many for the next one? I put the 4th person there. Now how many do I have left? 3, then, and if I can say blast off, I can use what? Factorial symbol. 5, 4, 3, 2, 1. Blast off. Okay, then we go to line up for the movie theater, the cinema. And how many people are there now? 4. So I can visualize them. 1, 2, 3, 4. It doesn't say someone has to stand at the front. It doesn't say someone has to stand at the back. It doesn't say anything like that, right? So there's no restrictions. I'm holding 4 people now. A little lighter of a load. How many do I have here? 4. Then I put 1 person there. Then I have 3. Then I put a person there. Now I have. And then I take the last person and like stand there. And 4, 3, 2, 1 blast off is 4 factorial. So really they want 5 factorial minus 4 factorial, which is 120 minus 24, which is? When we fill in numeric response boxes, what do we fill them in? From right to left or left to right?
Left to right.
Like you read. So we're going to go 9, 6. Do I have to fill in every box? Where is the decimal located? Do you remember?
Middle 2.
In the middle 2. There is no decimal in the front one. So if you want to go like 0.96, you have to go 0.96, right? Because the 2 middle boxes are the only ones with decimals. All right. The next one, we have a baseball coach, which could be overwhelming or very exciting if you've played baseball or not before, because you might feel like you're overwhelmed with it if you haven't. But remember, none of these questions can be partial to someone playing baseball and knowing the rules. If they're giving you a baseball thing, they have to actually state out the rules properly so that everyone has a fair chance of answering the question, right? So here we have a baseball coach is determining the batting order for 9 players. He is fielding. So he has 9 players. He already decided that Tony will bat cleanup, which they tell you that's position 4, just in case you don't know, which you probably don't. And the pitcher will bat last. Okay? Which expression will determine the number of different batting orders? If I'm doing batting orders, I'm putting 9 people out there, I'm going to do 9 blanks, because then I can visually see what is going to happen. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now they said that Tony has to be in the 4th one. Here's Tony. How many Tony is there?
1.
Sounds ridiculous because there's 1 Tony. That's how many Tony there is. So there's 1. And then we put the pitcher in the back spot. How many pitchers are there? The pitcher, they said. So 1. Now I put Tony in that spot, I have the pitcher in that spot. How many people am I holding in my arms? 7. And I can put any blank, but I like sequential, so I'm going to go 7. Put a person there, then 3, 2, 1. Does the 1 and the 1 do anything? No. So 7 to 1 is 7 factorial. How else could I have written it? We went over this the other day. Yep. How else would I have written it? With a P. How many do I have to choose from? Good question. There are, I'm saying how would I write 7? So be 7, pick how many? 7. Remember 7p, 7 is the same as 7 factorial, and they could give you interchangeable on the test, right, Kat? Yeah, totally. So 7 factorial is b. Or they could have put 7p7, which I know a few more people would have gotten wrong. All right. 3. This is another one where it's worded. Of the 4 parents on the executive of the school parent council, all of them are open to taking the role of president. All of them are open to taking the role of president, vice president, treasurer, secretary, except Ellen. She's like, I don't want to be president. That sounds stressful. Right, Matt? Yeah, totally. She has no desire to be president. How many ways can the executive committee be chosen? Now, is this a perm or a com? Does order matter? Yes, because they have jobs. The moment they have jobs, order matters, because you can be president, vice president, secretary, treasurer. If I was making a 4-person club, let's say, and none of them had jobs, then the order wouldn't matter if you were picked first, second, third, or fourth. You were on the club or on the committee. But we're giving them jobs, so order matters.
But it doesn't matter who gets what.
It doesn't matter who gets what, but it matters what position they get. So I'm not saying that this person has to be president or this person has to be secretary, but I'm giving them 4 positions, so all these positions have different roles, so order matters because you're getting a different role. So if I was picking a subcommittee of 4 people to be on a committee, but I didn't give them jobs, then would it matter?
No.
No, then it would be a combination. So the moment you give something jobs, it's a permutation, order matters. All right, so we have the president position, the vice president position, the treasurer position, and the secretary position. How many options do we have for the president?
3.
3, because Alan's like, no thank you. Now I had 3 for that. I throw 1 in that position. Now I grab Alan and I'm like, thank you, come join us. We will give you the rest of the position. So we grab her and we throw her in our pile. And how many do we have?
3.
3. Then we put 1 there. Then we have how many people?
2.
2, then 1. Which we can say is 3 times 3 factorial, which is 3 times 6, which is 18. All right. When asked to determine the number of distinguishable is a fancy word to just say you can tell them apart. Remember I told you not to let the distinguishable throw you off. They're going to say that every single time because that just means I can tell the difference between Lopp and Paul. If it was P-O-L and L-O-P, they're very different words. They're distinguishably different. Okay? Now, this is the key thing here. 3-letter arrangements. Words, is it a perm or a com? Does order matter with words?
Yes.
Yes. If not, my name is Crystal. You could call me Larissa, and it would be the same thing. I don't even know if I threw an S and a T in there. But anyways, if you changed my letters around, you could call me that, and it would mean that I should just talk to you because it's the same. Words are always permutations. Words or order always matters. When you get a word, what's the first thing I told you to always do? Yeah. Check if it has more than 1 letter. So I told you to rewrite it. So you would rewrite chipmunk. C-H-I-P-M-U-N-K. Lovely. I just rewrote the word chipmunk. That's just stupid. When I rewrite the word and I don't stack anything, that makes you happy, right? That means there's no double or triples. And if there's no double or triples, Mac, what does that mean? If there's no double or triples, what does that mean? I don't have a what? Starts with D, rhymes with denominator. I don't have a denominator. Exactly, good one. I don't have a denominator because there's no factorials that go on the bottom. If I have double or triples, I always have factorials. Cool thing is, if it's a 3-letter or a 4-letter or a 5-letter arrangement out of a whole bunch of letters, correct? That just means that you're not going to give me doubles or triples or it makes it harder. So if they ever ask for like 3 letters or 4 letters or 5 letters out of a bigger word, they're going to make sure the word doesn't double. Because if it doubles or triples, you'd have to do cases where you pick the doubles or you didn't pick the doubles and it would just be chaos. They won't do that to you. So the moment I add a 3-letter out of an 8-letter, I know it has to be no repetition. So I need a 3-letter word. I can either do it this way, 1, 2, 3. How many letters do I have for the first one? 8. Remember I had those sticky notes, C-H-I-P-M-U-N-K. So I stick up 1 sticky note. How many letters do I have?
7.
7, because there's a sticky note stuck there. Then I pick one of the letters and I stick it there. How many do I have for here? 6. So that works. How else can that be represented as a P? I have 8 letters. P. How many am I picking? 3. Same answer. Remember, these work? And that P you can only use if there's no repetition. We agree? And if there was no restrictions. So you have to go down by one number. We agree? So AP3 is the same as 876. So this one is good. This one is good. Then we're like 8 factorial. I really hope you know that that is not the same. So we pick that. But why is this one correct? Because this is actually the formula for NPR. So NPR equals n factorial over n minus r factorial. Remember we went over this one? So this would be 8p3 equals 8 factorial over 8 minus 3 factorial. And 8 minus 3 factorial is 5 factorial. So that's why D works. So 3 different ways. So they can ask you all the different ways. Correct? Yeah.
Can I go to the bathroom?
Yeah. Flipping over and work. No. This is one that I made you guys practice a whole bunch of times. We're practicing again. It's been about a week since we went through one like this. So this one says, how many odd 5-digit numbers are there without repetition? Now you have to watch if it says 5-digit numbers, how many blanks do we have? 5. So we have 1, 2, 3, 4, 5. And it says without repetition. So I'm going to box and hold. We know that? Now, 5-digit number means I have 5 blanks, but it also tells me that the first one can't be a what? Can't be a 0. Because if it was a 0, this would actually be a 4-digit number hidden as a 5. We agree? Riley, you got to put your phone away somewhere. Not there. All right. So your last digit has to be what, it said? Odd. So you have to keep this in your head because there will be one of these on your test. If you're like, I wonder if she's telling you the truth. She is. She's so boldly telling you because people won't study it and still do for them. So we're going to think about it and write this down and we're going to know. If it says odd, it means it has to end in an odd number. If it says 5-digit, it means it can't start with a 0. What if it was a 5-digit code? Then what? Could it start with a 0? Yes. So you have to watch yourself, 5-digit number or 5-digit code. So our back options are 1, 3, 5, 7, or 9. So I have 5 options. And then it says without repetition, so I have to box and hold one. I'm going to hold the 9. You could hold whatever you want. We agree? Then my first one can be 1 to what? I boxed and held 9. 1 to 8. 1 to 8 is how many numbers? 8. Hold the 8. Then I have 1 to 7, and then this is where the error happens. People will put 7. The answer to you putting 7 will be on the test. You will be wrong. What do I have to remember to do? Add the 0 back. Bring the 0 back. I couldn't use it in the last one because it was odd. I couldn't use it in the first one because it's a 5-digit number. Bring the 0 back so I get an 8. Hold the 0. Now I have 1 to 7, which is 7. Hold the 7. Now I have 1 to 6, which is 6. So we have 8 times 8 times 7 times 6 times 5. 13,440. All right. Number 6 says the number of ways to arrange the letters of the word, not work, that's a typo, learn. If the vowels must be together, what's the first thing I do when I have a word? Rewrite it to see if I have duplicates. And if I do, I'm going to have a denominator. If I don't, I'm not going to. So I rewrite learn. L-E-A-R-N. What I tell you if you're someone who skips things that I tell you to not skip? What's going to happen? You're going to get it wrong, or you might have an error. Chances of you getting it wrong increases when you don't show steps. So does learn have double triples? Nope. So we go to our 5 letters. 1, 2, 3, 4, 5. How many are vowels? 2. So I hook the first 2 together. Does it say in a certain order? So we can have how many for the first blank? Then 1. Then how many are left? 3, 2, 1. And I'm done? No, the answer to that being done will be there on your test. What do we have to remember to do? Times it by 4 because there are how many places to move it? 4. There's one case where it's at the front. That's 1, 2, 3, 4. So we get 2 times 4 factorial, which is 48, which is C. Now, this is one that I gave you specifically in here. I figured you'd pick it out, but you might not if it wasn't in this specific case after a few repetitions. But here it says a teacher has 4 identical math textbooks and 3 identical physics textbooks. We could look at that as the word It's the same thing, correct? They're identical, which means you can't tell the difference. It's the same as if you had identical vehicles. Remember how I told you there was a difference between if they were different models of vehicles or the same models of vehicles? If they were different models of vehicles and they were the exact same black, you could tell them apart, correct? But if they were the same model and same type of black, you wouldn't be able to tell them apart. So same thing here with these physics and math textbooks. So a person has been hired to clean the bookshelf of 7 books. That's hardcore. Removes all the books, cleans, and then randomly replaces the books. The number of ways this can happen. Did they restrict us to anything in particular? Did they say we have to start with a physics and end in a math? No. So this one's just going to be 7 factorial divided by 3 factorial, 4 factorial. Now, the catch here is, what if I asked you, 1, 2, 3, 4, 5, 6, 7, what if I changed this? What if I said has to start with a physics textbook and end with a math textbook? What if I said has to start with a physics textbook? How many options would I have for the first one? 3. Remember, we treat them in the numerator as if they're all different because the denominator gets rid of all the cases where they're the same, correct? And if I said it has to end in a math textbook, what would it be? 4. Now, how many textbooks have I thrown on this board? 2. How many am I still holding? 5. Nope. How many is there? 7? Yep, 5. Holding 5. So for the 5th one, I have 5 options there. I leave a textbook then. 4, 3, 2, 1. Difference between if there's restrictions or not. This one didn't have any restrictions, so it would have been D. But if it did have restrictions, even if you can't tell the difference between the physics and math textbooks, you have to write them out. Number 8 is on the bottom of your page, and it's one of these. Remember how we talked to you about these, and I talked to you about these as if they were words? Don't let them throw you off. You can treat them like they're the words easts and souths. Make sure... Phones. I'm going to have to literally take phones away like junior high. I don't want to, because you're almost going to be able to vote. We've discussed this before. If you should be able to vote, you should be able to handle your phones. All right. Really darn close. The next election, depending on when you're age, yeah.
We're screwed.
All right. So, but you could. All right. So let's look here. We have EESS. That's one word, correct? Can we put these together as one whole word, both of them? No, we have to treat them as distinct, separate words. So we have EESS would be the one part from A to the midway. And then we have EEE, 3 easts and 2 souths is the other part. So if I went to go do the word east, I would have how many letters? 4 factorial over 2 factorial, 2 factorial, which is 6, because it's 24 divided by 4. And then we have EEESS. How many letters is that? 5 factorial divided by 3 factorial, 2 factorial. Should be 10. 120 divided by 12. Do we add or multiply? Because they'll have both options there, just so you know. Always. They'll always have adding and they'll always have subtracting. Adding and subtracting. Adding and multiplying. My mouth was not saying what my head was thinking. Yes, you have to multiply. And you have to multiply because you're using what word? And or? And means you multiply, or means you add. We agree? So if I need this and this to get to B, I'm going to have to multiply. Now this was worded in a different way just to see what you would do. So the number of ways from part way to B and the number of pathways from A to B respectively. So part way to B is this one. So how many is that? 10. And how many total? 60. So you should have picked B. Okay, then here's another one with not together. I promise you, you're going to get one of these. You're like, I don't think she will. She's me and I make the test. You will get one of these. Okay? So, when you get one of these, you call me over and you're like, I remember you told me we would get one of these, but I didn't write down the work and I have no idea how to do this. I'll just smile at you and be like, yep, true. And then I'll walk away. It'll be a sad day. Okay? So, remember when we did not together, vowels not together, letters not together, when we do not together, and they will bold the not. When it's not together, you do total, I told you. Tell me how many people are in this school but not in this class. Trying to find all the people in this school that are not in this class would be ridiculous, right? And it would take too long and you'd probably miss a few. It'd be the same as trying to make all the cases where the vowels are not together. That would be time consuming and you'd probably miss a few, correct? So the fastest way to find the kids not in this class would be what's the total minus the kids in this class, and we'd know how many people are in this school and not in this class, correct? So when you get vowels not together, we always do total, all the ways I can rearrange whatever word I gave you, minus the vowels together, and then you're left over with the opposite, the vowels not together. So we have the word navigate. What's the first thing we do when we get a word? Rewrite it and see if there's any double ups or triple ups. So we have N-A-V-I-G-A-T-E. They will have the oopsie answer to you for getting divided by 2 factorial for the 2 A's. They will. So total no restrictions. How many letters are in navigate? 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 factorial divided by 2 factorial, which is a number of some sort. I don't remember what it is. So we get 20,160. So the word navigate, let's think about this. The word navigate has 20,160 different arrangements that would make it look different, right? If I went and rearranged navigate and I tried to make up all the cases, there'd be 20,160, so you'd miss a couple, or 100, if you tried to do this on your own, or you'd just get tired and quit, right? But that's all the different words I can get out of navigate, the distinguishable words. So, if I take that max and I subtract off the opposite of what I'm looking for, I'm left for what I am looking for. So the vowels together is easier to do. So it's 1, 2, 3, 4, 5, 6, 7, 8 letters still. How many vowels are in navigate? 4. And I'm going to instantly put the 2 factorial because it doesn't matter what the question is. I just found out that my hair moving and hitting the board does this, just so you know. I need to chop my hair off. Okay, that's what I've learned. All right, so there are 4 vowels. Hold the 4. How many do I have for the first one?
4.
Then 3, 2, 1. Then how many do I have left? 3, 2, 1. And am I done? Is that enough? No, what do I have to do? Times by 5 because there's more than one option where they're together. If it said together at the front, would I be done? Yes. So I times it by 5. And how many do I get? What did you get for an answer?
1,000.
Let's see. Oh, that's this. I get what you're saying. That's the vowels together, right? And then subtract from the total. Which is 18,720. So there are that many words where the vowels aren't together. Okay. Then we have number 10. Number 10 says, given the set of numbers 1, 2, 3, 4, 5, 6, that's a lie, 5, 7, the number of even 6-digit numbers greater than 500,000 that can be created without repetition. So I need to have 6 blanks. It just does stuff. 1, 2, 3, 4, 5, 6. It says it has to be even. So I know what numbers can be at the back. 2 and 4. And this question is actually really nice because the reason why I don't have a 6 up here is if I had a 6, I would actually have to do 2 cases. One where 6 could be the back number or one where 6 could be the front number. Do you see that? Because it could make it 500,000. But I didn't give you any bigger numbers that are even. So it resulted in 1 case. So we have 2 or 4. And the front has to be what? What's the only option we can have for the front number? if it has to be greater than 500,000. The 7, correct? Or what? Or the 5. Because our back number is going to be a 2 or a 4, which is bigger. Okay, so we use the 2 or 4. We have 2 options. Let's say I hold the 4. So I'm holding the 4 in the first blank. I just did the hair thing again, see? And did work ponytail. And then the first one is how many options? 2. How many numbers have I held? How many do I have left? 4. Does it matter what these are? So I have 4 then 2, then 1, because it says without repetition. So it should be 96. Yes, it's 24 times 4. All right. Then we have this one. Alexis bought 3 glazed donuts and 2 apple fritters from Tim Hortons to give to her grandchildren. That underline is not actually there. So Alexis bought 3 glazed donuts, 2 apple fritters from Tim Hortons to give to her 5 grandchildren. How many ways can she give 1 Tim Hortons treat to each grandchild? What do we have to spot here?
Multiples of the same thing.
There's multiples of the same thing, which means we have repetition, which means we're going to have a denominator. So we're going to have 3 factorial and 2 factorial on the bottom. That gets rid of the cases where they actually are not different. Then at the top, we treat them like we can actually tell the difference between them, correct? So how many blanks are we going to have on the top?
5.
5. 1, 2, 3, 4, 5. And how many do we have for the first one? 5 donuts then. 4, 3, 2, 1, which should get you 10. So 120 divided by 12, 10? Okay. And we're going to look at number 12. With the different arrangements of the letters of the word sponsor, I have a word. S-P-O-N-S-O-R. So I know I have 2 double ups. Must begin with 2 letters that are the same. The catch here is they could begin with the 2 S's, or means we do what?
Both.
We do 2 cases, and or means we do what?
Both.
Add. Or is add, and is multiply. Yes. So when we have cases, we actually add cases always. So no matter what, always add cases. So we have 1, 2, 3, 4, 5, 6, 7 letters. Or we're going to be able to multiply by 2, but I'm not going to do that. All right. So we still have 2 factorial no matter what. 2 S's and 2 O's. 2 factorial does no matter what. And it says begin. So are we going to move it around? If it begins? No. So we could have S or S, or we could have O or O. How many S's do we have?
2.
Then?
1.
Right. And it doesn't matter that we actually can't tell the difference. The 2 factorial gets rid of those cases. Correct? Now how many letters do we have left? 5, 4, 3, 2, 1. Then this would be 2 and 1. I just make sure there's 7. And then 5, 4, 3, 2, 1. So we could have actually just times by 2, correct? So it's going to be 120 divided by 2, so it'll be 60 times 2, which is 120. Then here, this one, pay attention, because this one gets done wrong all the time. The wording is kind of crappy. Sorry, it's my wording. So we have 4 different dogs and 4 different cats. They're different, which means there's no repetition. They don't look exactly the same. They can be arranged in line for a photo. How many different ways can the animals be lined up for a picture if no cats or dogs can stand beside each other? So that means no cat can be beside a cat and no dog can be beside a dog. So this is where I told you have to watch yourself when we have an even number. Please don't pack up at this moment. You still have lunch. You can chillax for a second. 1, 2, 3, 4, 5, 6, 7, 8. We can start with cats or we can start with
Dogs.
So you would get the same case, 4, 3, 2, 1, 4, 3, 2, 1 times 2. We did this one on the wall, remember? We did one like this on the wall.